In this video, I am going to talk about dependency inversion principle, the last principle of Solid. The links of the previous principles that were discussed are given in the description of this video. So what does dependency inversion principle states? It states that high-level modules or classes should not depend upon low-level modules or classes. Both should depend upon abstraction. Abstraction should not depend upon details, but details should depend upon abstractions. DIP characteristics. To implement dependency inversion principle, we have to create an abstraction layer using interface or abstract class. Implement the abstraction layer for both high and low level. Abstraction hides the details of the implementation. The last principle of Solid. So DIP is the last principle of the Solid principles. What is abstraction? In order to describe the dependency inversion principle, it is better to know about abstraction first. So abstraction involves hiding complex implementation details and exposing only the essential feature of an object. Focuses on what an object does rather than how it does it. As an example, we can say that when we take a picture in a mobile, then we can only see the picture that was taken. But behind the scene, how the mobile is showing us the picture, it remains hidden. Alright, now I will show a brief sample implementation about dependency inversion principle. But before that, the advantages of dependency inversion principle are: it has separation of concerns, it is easy to maintain the code, easy to understand, easy to test the code, increased reusability, and facilitates parallel development. Here, I have declared a user class with some properties, and I have a low-level class which has a method, and the method is returning an user object with some information, and this method is returning a user with the user information. And this is the high-level class, which is actually calling the user information method from the user data access logic class, from the low-level class. Here we see that the high-level class is creating an instance of low-level class, which means here high-level class is directly depending upon low-level class. So if we change anything in the low-level class, then we have to change this class as well. So it is violating the dependency inversion principle because high-level class is directly depending upon low-level class. Instead, it should depend upon abstraction. And also, it is not hiding the details. So if we go click on this, navigate to this method, we see that the implementation details is showing. So it is also violating the another condition of the dependency inversion principle. So now if we want to implement dependency inversion principle, what I have done, I have created an interface. You can also actually implement the DIP with an abstract class as well, because we are using the interface because the methods defined in the interface are actually by default abstracts method. So I have created an interface, user data access logic, which has a method defined. And in the low level class, I'm implementing the interface, and it is implementing the method of the interface, and it is returning the user information with one user details. So in the high level class, what I have done now, I have actually I have chosen to use the interface instead of directly creating the instance of the low level class. So here high level class depends upon abstraction, which means high level class depends on the interface, and I am calling the method using the interface. So if I navigate to this method, it is showing that it is not showing the details, rather it is hiding the details. So it is obeying the two conditions of DIP. In the program class, here I have created an instance of a high level class and passing the parameter of the low level class, and this is actually initiating with the interface. So since the low level class is implementing the interface, we can assign the class to the interface, and then we can call the method using that instance. So here we are not showing the details of the implementation, which is an abstraction. So if I run the application, the output is showing that has been populated in the low level class method. So I hope you have understood the BIP, and I will give the links of other solid principles that have already discussed. So you will find all the videos of solid series in the description.